In this presentation, we will walk through a proven engineering grade method to produce a highly accurate material takeoff from engineering drawings. This approach is used by experienced process, mechanical, and piping engineers on real construction and EPC projects. The goal is not only to count materials, but to produce a takeoff that is accurate, traceable, and defensible. Step 1. Control the drawings and lock the scope. Before measuring or counting anything, always start with drawing control. Confirm the drawing status. Check whether the drawings are issued for construction, issued for tender, or for information only. Record the drawing numbers, revision numbers, and issue dates. Clearly define what disciplines are included and what is excluded. This step prevents scope creep and avoids disputes later in the project. Step 2. Read the drawings like an engineer. Never start measuring immediately. First, read all general notes, legends, and standard details. Understand the system purpose, flow direction, and operating intent. Identify equipment tags, line numbers, materials, and design standards. This builds a complete mental picture of the system before any quantities are extracted. Step 3. Define a clear MTO structure. A perfect material takeoff is structured before it is quantified. Divide the takeoff into logical sections such as equipment, piping, valves, supports, instruments, and miscellaneous items. Each line item should represent one measurable and purchasable component. Clear structure makes the takeoff easier to review, price, and audit. Step 4. Scale measurement correctly. Scaling errors are one of the most common causes of wrong quantities. Always use the drawing scale bar, not the written scale. Verify the scale using at least 2 known dimensions. For piping, measure centerline lengths and keep fittings counted separately. Recheck the scale whenever the drawing revision changes. Step 5. Count systematically and mark the drawings. Never rely on memory. As you count items, visually mark them on the drawing. Use color coding to distinguish between piping, valves, supports, and instruments. If an item is counted, it must be marked. If it is not marked, it is not counted. This prevents omissions and double counting. Step 6. Include fittings, valves, and special items. Straight pipe alone does not represent the full scope. Always count elbows, T's, reducers, flanges, gaskets, and bolts separately. Valves must be counted by type, size, and pressure class. Pipe supports should be counted by support type and location, not estimated blindly. Step 7. Cross-check against other documents. A professional takeoff is always cross-checked. Verify that all valves shown on process diagrams appear in the takeoff. Confirm that all equipment nozzles have associated piping. Check that line sizes and materials match the line list and specifications. Any mismatch must be resolved before issuing the takeoff. Step 8. Apply engineering allowances carefully. Allowances should be applied intelligently, not automatically. Typical allowances may include a small percentage for pipe cutting waste or bolting losses. All allowances must be documented clearly. Never hide allowances inside quantities. Transparency is critical. Step 9. Build the final MTO table. The final takeoff should be presented in a clear table. Each row should include description, material, size, unit, quantity, drawing reference, and remarks. Use consistent terminology and material specifications. This table becomes the foundation for pricing, procurement, and construction planning. Common mistakes to avoid. Avoid mixing drawing revisions. Do not ignore general notes or standard details. Never estimate supports or fittings without reference. Avoid counting from screenshots instead of original drawings. Accuracy depends on discipline and method. A perfect material takeoff is traceable, repeatable, and defensible. If another engineer can reproduce your quantities using your markings and tables, your takeoff is correct. Thank you.